Alright, let's do some examples which do not require any techniques actually. For example, let's compute this integral d, or maybe I should say r 3dA, where r is this region, uh, x coordinate is between a and b, and y coordinate is between c and d. So r is this region here. It's a rectangle. Okay, it's a rectangle. R is this, and we would like to compute this. Well, of course, from the properties of double integral, first of all, 3 goes out because integration is linear, and then you have the integral of this. Ne oldu böyle? Okay. Şöyle yapayım. Okay. 3dA, 3 goes out, you get 1dA, and integral of 1, right? We had that one over here. Integral of 1 is just area of the region D. So this is just the area of, so this is 3 times area of the region R. And what is that region? What is that area? R is just this rectangular region, and its area is just the product of its sides. So it is B minus A times D minus C. So this integral is just, easy to compute. Let me do this one. So let me call that integral I over this region, which we represent like this, which function sine x plus y cubed plus 4dA. So region is this region. It's the disk of radius 1. Okay, it's this disk, and we would like to compute this integral. This integral, since this is a sum of 3 functions, I can write it this way. This is just integral of sine x, x squared plus y squared less than 1, dA, plus integral of y cubed dA, x squared plus y squared less than 1, plus integral of 4 x squared plus y squared less than 1. And let's look at these integrals one by one. Well, for the first integral, note the following. Whenever you pick a point here, x comma y, this region is symmetric, and you have here minus x, y, right? Its reflection with respect to the y-axis is this point. And sine function evaluated at this point. So this is a function of 2 variables, but it's a function of x only. This function evaluated at this point and this point, right? One of them gives you sine x, the other one gives you sine minus x, which is minus sine x. So this means what? This means the following. The integral over this half of the circle is the same as the integral over this half of the circle, but the signs will be opposite. On this side, sine function will have positive values. On the other side, it has the same values but multiplied with -1. So it's like, in a single variable function, it's something like this. Okay, here you have a positive area and then negative area, but they have the same size. So the total of the integral is 0, right? The same thing applies here, and this integral is just 0. What about this one, y cubed? Well, actually, it is the same, something similar. Why is that? Because, whenever you have a point x comma y here, x comma y, you have x comma minus y, because again, circle is symmetric with respect to the x-axis, and therefore, and the function has the same value, but, opposite values. Here, this function will take positive values, and on the lower circle disk, it will have negative values, but the values are the same. The value at y and minus y are the same in size, but the sign is different. Therefore, integral over this piece and this piece will have the same magnitude, but they will have opposite signs. Therefore, the sum again will be 0. And what about this one? Well, this is just 4 times 1 dA, x squared plus y squared less than 1. And this is just 4 times area of this region. Well, this is just circular region of radius 1. So area is just pi r squared, just 1 squared. So it is just 4 pi. So this integral is 4 pi. Here we made use of the fact that if you have a symmetric region, and if your function is positive on one half and negative on the other half with the same values, then the integral will be 0. Okay. All right. So far, actually, we haven't seen any, significant technique to compute the double integral. That's the content of the second section. Iteration of double integrals in Cartesian coordinates. Coordinates. Let's see, what do we mean by this? Okay. We will talk about simple regions, x simple and y simple regions. First, let me say y simple region. What's this y simple region D? It's something like this. In the D coordinates, it is, in the y coordinate, it is simple. Namely, something like this. Suppose you have two graphs, y equals, okay, c of x and y equals d of x, and your region is this one. Okay, this region. So D is the following: consists of pairs of real numbers. so that x is between a and b and y is between cx and dx. Okay, a region like this is called y simple. In y coordinates, it is the it is between two functions. Okay, in this case we call it y simple, and we have similarly x simple region d. What's this? Just take this and rotate 90 degrees, so you get something like this. Okay, something like this. So a region like this is called y simple. Here, let's say this is x equals a of y, and this is x equals b of y. So here you see, for any x value, here, this point is cx, and this point is dx, right? So this is just cx, and this is just dx. Here, uh, it is the other way around. For any y value, I have this and this point. This is a y, and this is by. Okay, you just replace the roles of x and y. Okay, these are simple regions. Why do we call them simple? Because integrals over these regions can be computed in a simple way. Okay, that's why they are called simple regions. And here is actually okay. Uh, a region a region okay, a region D, which is the union of non-overlapping overlapping uh, finitely many simple regions. They can be x simple or y simple, is called a regular regular domain, regular region. For example, this thing, uh, suppose we have something like this. So our region is this. Okay, so this region is uh, neither x simple nor y simple. it is not a region between two graphs, right? X simple means something like this. Y simple, no, this is Y simple, and X simple is something like this. This is not, it's not like this or like this. However, I can divide this into uh, 4 pieces so that each one is a simple region. Okay, namely, okay, let me divide it like this, and then like this. Efendim? Aslında öyle de olabilir. Şöyle, yani şu da olur aslında. Ee, yani bir bölge, so one region is this. One region is this. Oops, pardon. Right. This is y simple, right? Why is that? You see, I have this curve. So this is a graph of a function. Let's say this is y equals uh, cx, and uh, this part, right? This is y equals dx. So this region is y simple, right? Y simple. Hı. Olmaz. Neden olmaz? Bak, tanıma bakalım. Y simple ne olacak? Y simple, both graphs are over the same interval AB. Okay? Yani bir tane x üzerinde bir interval var, AB diye. Bu interval üzerinde tanımlı 2 tane fonksiyon var. O fonksiyonların graflarının arasında kalan bölge. Şimdi sen sadece şeyi alırsan, yani bu kısmı alırsan, sadece burayı alırsan, şimdi burası bu interval'da tanımlı ama yeşil burada tanımlı. Aynı interval üzerinde tanımlı olmazlar. O yüzden de bunu şöyle yapmak lazım. Bunu şöyle yapmak lazım. Yani bu şöyle. Tamam mı? Yani burada AB intervalım şu olacak. İşte A, B, bu Cx fonksiyonu, bu da Dx fonksiyonu. Aynı şekilde tabii lower part'ta, right? Similarly, the lower part is also y simple. So this is a region. It's a union of two y simple regions. Therefore, this is a regular region. Okay, so regular means it's a union of finitely many simple regions. Peki, buradaki teoremde şu, yani niye önemli bu? Teorem, iteration of double integrals. If fxy is continuous, so we always, ask f to be continuous, otherwise things can be crazy. So you cannot expect anything on the bounded y simple region D given by uh, x between a and b and uh, y between cx and dx, then the double integral of f, niye bu integrali güzel yapamıyorum? Okay. Şöyle. fxy dA is equal to the following. First, okay, I have this notation, meaning that sevmediğim bir notasyon ama neyse. Okay. A, B, C, X, dx, fxy, dy. Uh, Similarly, I will explain this notation. Similarly, if f is continuous on the x simple region d given by y is between c and d and x is between ay and by, then the double integral of f over this region is just cd dy and then ax, no, ay, sorry, by fxy dx. Okay, let me explain what these are. Uh, First, let me talk about y simple region. So I have this AB and I have our region here. So this is y equals cx and y equals dx, and this is our region D. Okay. So theorem is the following: if f is a nice function like continuous, f of xy dA, this integral can be computed as follows. First, you integrate, okay, let me write. So this was AB dx and then cx dx fxy dy. So what we mean is this. First, you integrate f as if it's a function of y only. You keep x as a constant and you integrate this object with respect to y. And uh, it's like partial differentiation, right? When you are differentiating a several variable function, like let's say function of x and y with respect to x, you keep y as if it's a constant and you just differentiate with respect to x. The same thing here. In this integral, I will just keep x constant as if it's a constant and regard this thing as a function of the single variable y and integrate it. This is something we already know, right, from one variable calculus. Integral of a single variable function over some interval. You see, when x is fixed, cx is the number, right? X is like 5. So this is the number. This is another number. So integral from, let's say, 5 to 10 of f5y with respect to y. You see, here when you plug 5 for x, x disappears. You have only y left. Single variable function, and you can integrate this. You integrate this gadget, you obtain an, an answer depending on x, right? Because as x changes, this integral will vary. And then, so this whole thing is a function of x, right? This whole thing is a function of x. And then you integrate this function with respect to x over the interval ab. So what you are doing on this graph is the following. For fixed x, okay, you have this interval from cx to dx. You integrate fxy with respect to y, right? This is the y-axis. Yani y eksenine göre integral alıyorsunuz. Elde ettiğiniz ifade x'in bir fonksiyonu. Sonra da bu x'in fonksiyonunu a'dan b'ye entegre ediyorsunuz. Tamam mı? Bu bir tabii ki bariz olmayan bir teorem. Hani bu ispat gerektirir ama ispatları dediğim gibi atlıyoruz. İspatı da çok da kolay değil. Hani bir sürü teknik şey var. Zor da değil ama hani teknik meseleler var. O yüzden atlıyoruz. Diğerinde ise bu sefer tersten yapıyoruz. Önce x'e göre integral. Elde ettiğimiz ifade bu y'nin bir fonksiyonu olacak. Sonra da onun y'ye göre türeviyoruz. Right? In this case, we first integrate with respect to x. You get a function of y and then you just integrate that function of y from y equals equals c to y equals d. All right. Now let's do some examples. Belki example'dan önce notation. This double integral over a region can be written like this: dx dy. dA is replaced by dx dy because dA is something like this. This has, let's say, length dx, and this side has length dy. dA is just the product of these two, okay? It's considered like that. So dA is just dx dy. I can also write as dy dx, doesn't matter. They all mean the same thing. But here, I mean, it is important whether you have x or y, okay? Here you have to be careful, but in this, it doesn't uh, mean something else. Bir başka notation da şu: this integral, let's say a to b dx cx to dx fxy dy is also denoted as, bu şöyle de denote ediliyor. Yani bunu da görürseniz ben aslında bunu kullanırım genelde. A to B, you write this. Cx dx fxy dy inside parentheses. So you take integral with respect to y. What you get is a function of x, and then you just integrate with respect to x. Okay? This notation and this notation are the same. Similarly, this notation c to d dy ax bx fxy dx is denoted as, şöyle de bu ifade edilir. C'den D'ye integral from ax to bx fxy d x, and then I have dy. Some books use this kind of notation like our textbook, but some books prefer this notation. Okay, they mean the same thing. I also like this notation, but I will stick to the book's notation. Usually physicists use this one. Okay, I find this confusing, but doesn't matter. Let's do some examples. One. Okay, find the volume of the solid lying above the square Q defined by this, pardon, 1, Y, 2, and below the plane Z equals 4 minus X minus Y. Yani şunu hesaplamamızı istiyor. Region'ımız X coordinates change from 0 to 1. So 0 is here. Let's say 1 is here. Y coordinates change from 1 to 2. 1 to 2. So our region is something like this. Okay, so this is our region D, no, Q. And above this, we have the graph of the following function. Z equals 4 minus xy. Nasıl bir şey bu? This is a graph of a plane. So this point is 4. Right? When x and y are 0, z is 4. When okay, x is 0 and y is 4, z is 0. So it passes through this point, and again it passes through this point. So this is the plane containing these 3 points. So it's a plane like this. Bu noktanın orijine olan uzaklığı nedir? Bu nokta hangi nokta? 1'e 2. 1'e 2'nin orijine olan uzaklığı 1'in karesi 1, 2'nin karesi 4, 5, karekök 5, 4'ten küçük. Dolayısıyla yani şöyle bu tabii benim çizdiğim kısmıyla şey oldu da şöyle biraz daha dikkatli pardon yapmam lazım. Şöyle yapayım. Şunu biraz daha uzatayım. Şunu da belki birazcık şöyle alalım. For so it is this plane here. Above this, so what is our region? This is the base, okay? It's a rectangular region. And above this, we have this, roof, right? And we have this, let's say, object, something like this. So, okay. Yani çatısı eğik olan yani bir tane dikdörtgen prizma var. Şöyle onu bir düzlemle kesmişsiniz. I am asked to find the volume of this. Okay, volume of this. So what is the volume of this? Well, so volume of that object is what? Volume is the following. It is just the double integral of 1 dA, right? No, not of the height function. Height function is so f x y dA. What is f x y? This is z equals f of xy, 4 minus x minus y, right? This is the volume. At any point, you go up and you look at the height of the, line from the bottom to the top. Yani zeminden tavana kadar olan yüksekliği ölçüyorsunuz her noktada. O fonksiyonun bu bölge üzerinde integralini alıyorsunuz. So you just integrate the height function, right? Height function over d. So what is this region? D is, what was this? D was the following: x from 0 to 1, y is 1 to 2. So this is just a simple region. It is simple in both x and y, right? It is this region here. Let's say 1, 2. So it is this region D. It is simple in both functions. And our function is this 4 minus x minus y. I can write it in any way I want since it is simple in both x and y. For example, first let me, okay, integrate with respect to x, and then I'll integrate with respect to y. X is changing from 0 to 1, y is changing from 1 to 2. Okay? So this notation means you first integrate with respect to x, and then whatever you get, you integrate that thing with respect to y. Let's do that. 1 to 2 dy. What is this? Integral of this expression with respect to x. I will regard y as if it's a constant because x is my variable, so y is considered as a constant. How would you take integral of this? Well, you need to just anti-derivative take the antiderivative of this with respect to x. What is an antiderivative for 4? For the constant 4? Just 4x, right? Yani türevi 4 olan, x'e göre türevi 4 olan fonksiyon istiyorum. What is the antiderivative for x? Well, that is x squared over 2. What is the antiderivative for y? I consider y as if it's a constant. Therefore, this is just x times y. And this whole thing is integrated from 0 to 1. So I have this. Yani y'yi sabit gibi görüp x'e göre integral aldım. Başka bir şey değil. I plug the end values. So when you plug 1, you get 4 minus 1 over 2 minus y minus I plug 0, 0 minus 0 minus 0, right? You get this. Yani x yerine, değil mi? X'e göre integral aldığıma göre x yerine 1 koydum. Sonra da x yerine 0 koydum. Dikkat ederseniz y'li bir ifade çıktı. O zaman şimdi bunun integralini alacağım. İfadede nedir? 7 bölü 2 eksi y dy from 1 to 2. I integrate this, well, with respect to y. This is 7y over 2 minus y squared over 2 and integrate from 1 to 2. So when you plug 2, you get y yerine 2 koyarsanız ne çıkar? 7. Buradan da 2. Eksi y yerine 1 yazıyorsunuz. 7 bölü 2 eksi 1 bölü 2. Burası da 5 eksi 3 mü ediyor? 5 eksi 3. Right? So this is just 5 minus 3. This is 2. Yes. All right. So let's give a break. After the break, I'll continue.